Whenever I hear the word teletype, I think of this 100-year-old beauty next to me, which is funny because it's not even technically a teletype. This is a 1925 Morkram-Kleinschmidt Model 14 teleprinter. But also it is a teletype. If you look at the motor here, it says Teletype Corporation on it. And in the mid-1920s, the Morkram-Kleinschmidt Company and the Teletype Corporation fused in some way. The deal is 100 years old, and the intricacies of how it went down are a little bit beyond me. I'm sure it was wild by whatever we consider to be normal today. But essentially, Morkram-Kleinschmidt became Teletype, and I kind of view this as the first proper printing teletype, which means that this is an incredibly important machine in the world of computing history, because the way that teletypes work is that they receive 5-bit serial data and translate that into some kind of mechanical motion that swings a hammer to print human-readable text on a piece of paper. And it seems weird for me to say that this machine is important for computing history, given that it's from 1925 and computers were certainly not around then. But this concept of receiving digital serial data and converting it to something human readable, and then taking an input on a keyboard and translating that into digital serial data that can then be sent out, is a concept that still exists today. A lot of new, modern, enterprise-grade equipment still uses 8-bit ASCII data sent serially through a data terminal. So yeah, this 100-year-old machine can draw a direct lineage to stuff that is still in production today. And with the Teletype Corporation acquiring Morkram-Kleinschmidt, they got to work on a much better teleprinter that was released in 1930 called the Model 15. I also happen to have one of those, and it is a beautiful combination of mechanical engineering and electrical engineering, and it's just mesmerizing to sit down and watch. I am absolutely in love with it, as was most of the world in 1930. The Model 15 sold like hotcakes and made Teletype Corporation an absolute juggernaut. And they continued to produce those things for like 20 years. They made a bunch of different models, but some of the highlights are in 1951, they released the Model 28. This was kind of like a desk-sized thing, and it's really wild in the way that it prints. It has this like block that it moves around and a hammer that hits a particular letter on that block. Fascinating to watch. Then in 1963, they released the Model 33. And in the 1960s, we were seeing transistorized computers starting to become more commonplace, and the Model 33 changed from the 5-bit Baudot that was being used for these old teletypes to 7-bit ASCII. And that cemented the Model 33's place in computing history. It became the de facto standard for input-output for a large number of machines. The Data 620 that I have sitting here in this room that we're gonna get to this year used a Model 33. The PDP-8, one of the most legendary machines on the planet, used a Model 33. Teletype was still an absolute juggernaut. But by the time they rolled into the 1970s, things started to change. Computers were wanting to print out more and more information to show the user, and that was becoming quite wasteful for paper. And so some companies started developing things that they called glass teletypes. And these had been around for many years, even in the 1960s, but they didn't really become commonplace until about 1976 when Lear Siegler released the ADM-3A. Now, like I said, that's not the first glass teletype data terminal, but it was certainly one of the most prolific. It did what the Model 33 did. It changed the landscape. And there was this large shift towards having all of the information printed on a CRT monitor as opposed to printing on paper. However, Teletype wasn't quite ready to give up the jig, and in 1977, I believe, they released this machine right here. This is a Model 43 Teletype. It prints the paper, and I believe that this is the last paper printing teletype that was ever made. Teletype Corporation did try to get back into the game with a glass teletype of sorts in 1979 with the data speed 40, and they may have had a couple other swings at it, but pretty much the writing was on the wall. Companies like ADS producing this gorgeous ADS Regent 100, you had DEC making the VT 100, and of course you had ADM 3As out there coming out the wazoo. They were everywhere. But I think it's pretty special to have this Model 43 teletype as the last printing teletype and this Model 14 teletype as the first printing teletype right here on the table. Now, this Model 43 does do 7-bit ASCII, so I can get this hooked up to a computer, and it does it at 100 baud and 300 baud, I believe. So I should be able to just plug a cable into the back of this, plug it into the Centurion, and use this like a data terminal for the Centurion, only it's going to print it out on paper and make a huge waste, and it's going to be brilliant. But that's not actually why I have this machine. I have this machine as the primary input-output for another mini computer that we're going to jump into really soon. I'm very, very excited about it. I'll show you a little sneak peek right now, but I'm not going to say it out loud because, well, we'll just get to it when we get to it. Because first things first, we got to get this Model 43 going, and I'm very excited about this. So let's get into it. This Model 43 was donated alongside the Nova by the very excellent Robert. So Robert, if you're watching, thank you so much for these. We're going to get both up and running for sure, starting with this teletype. And once we've got the cover and ribbon removed, let's get to work on getting the entire thing free of its plastic cage. The platen knobs just slide right off. Then there are 2 screws holding the paper guide in place. These screws also do double duty and hold the back plastic panel on, and with them removed, it just pulls free and clear. There are 2 more screws at the front corners, and with those out of the way, the entire thing can be pushed backwards, sliding it completely out of the plastic case and onto the bench. The power supply only has this small ribbon cable, and the fatter ribbon cable looks like it's dedicated to the RS-232 port. With both cables disconnected though, we can then pry out on the snaps that hold the power supply in, and there's a snap on each end, and with those loose, the whole supply can then be lifted straight up, pulling it completely free. Let's get to work getting into the power supply next. There are 2 more snaps that come loose with a little quick and easy prying. Then the power supply itself can be pulled free of the rear mounting plate. To get into the power supply proper, there are 6 screws on this flat plate. Then the whole plate can be pried up and off, giving full access to the supply. This is about as far apart as I'm gonna take this thing because honestly, this Model 43 has me a little nervous. I'm usually a little lax about static control in this room because it's Texas and static discharge is really not that big of an issue down here. But also 99% of the time I'm working with 7400 series logic chips, which are tough as nails and ubiquitous. Or I'm working with vacuum tubes, which Thor Almighty himself could load up with lightning and they just wouldn't care. But this Model 43 teletype uses something called BiMOS, which takes the technology of bipolar transistors and the technology of metal oxide semiconductor transistors and fuses them onto the same silicon die inside of a single IC, which seems like a terrible idea. And so while 7400 series stuff is generally tough as nails, the BiMOS chips in here I've heard are about as tough as a wet noodle. So we're not even gonna risk it unless the machine is already broken, at which point in time we'll take it apart and dig in and try to figure out what's going on. But right now I was told it ran when parked, so we're just gonna clean it up, make sure that the power supply here is not outputting any insane voltages and that there's no like wild shorts or anything like that on it. And then we'll put it back together, power it up, and hopefully it just works. If it doesn't, then we got to try and figure out what to do about that BiMOS stuff. But I'm going to get to work on this power supply first. The supply has some weirdness to it, like this capacitor that has 4 legs, 2 on each side. I've never seen one like this before. Also, all the power delivery is done through this tiny little connector and an equally anemic 10-pin ribbon cable. I know that these can move some power, especially if the pins are doubled up, but still it just doesn't feel quite right. At any rate, I do want to check this big chonker of a capacitor. Since it's bolted in place, I can remove it moderately easily and get it out on the bench. Hooked up to my LCR meter, look at that. It's a 200 microfarad rated capacitor and it's showing 191 microfarads. These old Sprague caps are surprisingly reliable. The other caps are all still in circuit, so I'm just going to check them for any shorts, and that should be good enough for an initial test. All right, we're going to try powering this thing up for the first time. I have no idea how it's actually going to behave. Some switch mode power supplies really don't like being powered up without a load on it. So we may not actually see anything meaningful come out here, but we're going to give it a shot anyways and just see what shakes loose. This power supply produces 4 volts. It produces plus 42 volts, plus 12 volts, plus 5 volts, and minus 12 volts. And I think I've figured out enough of the pinout, so we should be on either plus 5 volts or plus 42 volts right now. So let's flip the power switch on and hopefully we don't let the magic smoke out. 4.99 volts, that's, that was on the plus 5 volt rail. All right, let's see if I can get this over to another voltage rail here without creating a short. That should be plus 42 volts. And yeah, 42.2 volts, that looks great. We should have minus 12.1 there and plus 12.06 there. That all looks fantastic. All right, I think we're clear to clean this thing up, put it back together, and try to power it up for the first time with everything connected. It wouldn't be an official Usagi Electric Teletype video if there wasn't some simple green somewhere in here. I'll soak the plastic pieces and then give them a good scrub to clean them up. Then they get a nice little spray down with the hose, and while those are outside air drying, I'll get to work cleaning up the rest, starting with the platen. This machine uses tractor feed, so the platen doesn't really have to be all that grippy. It just needs to be clean enough that the paper doesn't get dirty. Then I'll contort my hand inside the machine and try to clean up all the excess grease that's dripped down. With everything looking a lot cleaner, I'll re-grease up the screw and slider that control the location of the print head. And then next I want to get the keys clean, but I'm not sure how to remove the key caps, so I'll just clean them as best as I can in situ. It's all coming up Millhouse, so let's get this thing slid back into the main plastic housing. And don't worry, the night is still young. I'll remove and reinstall this thing at least 5 more times before the video is over. Finally, let's see if we can revive this ribbon a little bit. I'll crack it open, and then on the inside there's a sponge that holds ink. The ink on this sponge gets transferred to the transfer roller, which then re-inks the ribbon as it's pulled by. Unfortunately, the sponge seems like it's seen better days. I'll just try to let this new ink soak in for a bit, but I'm a bit skeptical. Okay, we've got all sorts of interesting problems. My ribbon here is a little too stretched out, so there's no tension on it like there should be, so I don't know if this is ever actually going to work. Also, the paper that I bought is 8.5 inches wide, and it needs to be like 11 inches wide, but not 14 inches wide. It's a weird size, like in between. I didn't realize that there were an option in the middle there. But we're going to turn the power on and see what happens anyways. And even if the re-inking here, which got all over my fingers, does work, I imagine it's going to take a lot of cycles through there before it actually soaks into the ribbon, if the ribbon even will cycle. So, well, let's see what happens. Well, it powered up. We have an alarm on here and it says local. None of this is doing anything over here. All right, check this out. I've discovered that if I press and hold the printer test button, it actually just tests the printer. We're not really printing anything, but I can see the ink on the ribbon starting to work its way across. So I can actually see some letters starting to kind of show up. We're gonna let it go like this for a couple cycles more, and I think we might actually start getting real deal legitimate prints coming out. Oh, we got just a tinge of it there at the beginning. Oh, look at that. We're starting to get into the inked portion. The inking is really inconsistent. That's to be expected. It needs to make a bunch of different loops around to fully saturate the ribbon. But it is legitimately printing something. Uppercase and lowercase, printing correctly. I think that's a indication that a large majority of the circuitry inside this thing is functioning. Before I go too far, I gotta get some proper tension on the ribbon. I built this little post that bolts in and gives the ribbon an extra location to route around. This makes the tension perfect without actually getting in the way of anything else. This thing has me just chasing my tail here. I cannot get the alarm light to turn off and for it to come out of local no matter what I do. And looking in the documentation, it says the alarm light kicks on when the cover is open, but I don't see any cover interlock switch anywhere on here. And I have been hunting for a while until I realized that the cover interlock switch is supposed to be right here. It is missing. That's definitely going to cause a problem. So I'm going to try and figure out how to jumper across that or short it or, I don't know, figure out some way to bypass it because I clearly don't have a spare one of these types of switches. So let's see if we can get to the underside of the keyboard PCB. There are two screws on the sides that lock it in place, and with those loose, the keyboard just rotates right out. Then we can disconnect the ribbon cable and, man, despite my best efforts, it looks like we're trading blows with the BiMOS chips anyways. I'm fairly certain that these two gorgeous ceramic ICs are the ones in question. They have Teletype specific part numbers and are probably the rarest ICs in this entire room. Back over to the keyboard though, there are 4 screws around the periphery that hold the cardboard cover on. With those removed, the cover can be slid off of the ribbon cable, giving nice access to the bottom of the keyboard control PCB. And would you look at that, someone has already jumpered across the missing key switch. And digging through the manual to confirm, yep, if these two contacts are connected, that means that the cover is on. So this is clearly not our problem. All right, the only other thing that can cause the alarm light to come on and stay on, not flash, but stay illuminated, is the paper out sensor. And the switch for it is right here. I've got my multimeter plugged into it and it's showing 8 ohms, 8 kilo ohms. So the sensor is right here, and if paper comes through, it should push it up. And that never changes. I don't know if the switch itself is broken or something, but if that never goes, then we got a problem. Fortunately, it's pretty easy to get the push switch out. It's just 2 screws through the body of the switch, and then the whole thing is completely free. With it fully removed and on the bench, it looks to be a good switch, so maybe the issue was corroded contacts. In this photo, the 2 outer contacts are after I took some sandpaper to them, but the inner contact is how all 3 looked before. That's pretty corroded and nasty. All right, I did a little contact cleaning, and even though there's no paper in it, you can actually pull the lever all the way back and snap it all the way open, which should allow this contact switch to be essentially saying that there is paper in it. So let's flip the power switch on. We want to see this alarm light go off, please. Yeah, all right. It says term ready right here. I think that means that we're good to start sending and receiving data. Okay, I think the first step is to try and get a loopback connector working so I can understand the pinout, and then maybe we'll try to plug it into a computer. All right, here's my loopback connector. I've got transmit and receive looped, and then I've connected data carrier detect to data terminal ready. I came up with that by looking at a whole lot of schematics and notes in the manual. So we'll go ahead and plug this in the back here. And with that plugged in, I should be able to type. Yeah, check that out. We are sending and receiving data. I think it's safe to say that this thing is functioning. Now I just got to figure out what baud rate and bit selection I need to set it to, and we can hook it up to a computer. Okay, I've got the Centurion spun up, and we're going to try and get this as a second data terminal on the Centurion, but it's set up very janky, and I'm absolutely not expecting this to work properly the first time, because the 9-pin coming out of the Centurion is custom. It predates the IBM standard that we're all used to. And so that 9-pin comes out and goes into a standard DB25, which is close, but it doesn't have the DCD to DTR signals in there, and I can't short them. So I go from that 25 through a gender changer into a 25 to 9-pin converter, then through another gender changer into my 9-pin breakout box, and then I do my jumpering and swapping of things like I'm supposed to there, and then I go 9-pin back up to 25-pin to this. It's the most janky RS-232 thing I've ever seen, but we're gonna give it a shot. In order to do that, I need to set up CRT2, which is what that one's plugged into, to be the correct speed. So I'm gonna run a little utility here called MuxGen. The number of data bits is 7. There is even parity, 1 stop bit, and the baud rate is 300, and that is CRT2. All right, that's set up. So I'm gonna reach down here, I'm gonna press Control C, and we're hoping to see CRT2 ready print out on this, but I'm not expecting it to do that. Yep, we still got something hooked up very wrong. Okay, I'm gonna mess with it for a little bit. Okay, I got rid of the jumpers. I had them crossed over because I was doing some testing later. Let's see if that solved it. We're gonna do Control C again. Yes! We got CRT2 ready. If I hit return, yeah, it gives me a date. All right, let's do this. .sta, hit enter. There it goes. It's working as a data terminal. Runs straight off the edge. I need wider paper. I absolutely need wider paper. That's on the way though. All right, let's grab a directory listing, and that should not run off the edge of the paper and should look a lot cooler. Okay, so we'll do a .dir space 1, hit enter. This should be a directory listing of the fixed platter of the hawk drive that's on right now. And yeah, it's printing it right on out. We got to a kind of a weak spot in the ribbon, it looks like. Hopefully that'll move around and we'll get dark again. There you go. This is a fully functional data terminal hooked up to the Centurion, running at 300 baud, printing out our directory listing with absolutely no problems whatsoever. This little Model 43 Teletype is an absolute beaut. The Teletype out here proving once again that they're the kings of the printing Teletype game. This thing, man, I love it. It's great. But it does have some problems. I absolutely have the wrong paper in it. This paper doesn't feed right because it's not wide enough to hit the tractor feed. But there is still a manufacturer out there that makes that type of paper, and I've got some on order. So the next time you guys see this Teletype, it will have the correct paper in it. Also, that ribbon is just gonna give us grief, I think. I did get that tensioner in there that properly tensions the ribbon like it should be, but man, the little foam roller on the inside that's supposed to hold all the ink just felt like it was hard as a rock. I am gonna keep putting ink on it, so hopefully it will eventually start transferring ink back into the ribbon and we'll get back to having dark prints. So that's gonna be a bit of a challenge, but it works beautifully well. It's running excellently as a data terminal, and ultimately it's not gonna be running on the Centurion. It's going to be running on another mini computer that I am very, very excited about. So I hope you guys are as excited about it as I am, because there's going to be a lot of it coming up. So I want to thank you all so much for watching, and I hope to see you in the next episode.